parallel interconnected two-port circuit. This connection is called parallel because uh, input ports of the two circuits A and B are connected in parallel, and output ports are also connected in parallel. So at input we have parallel connection, and at the output again we have parallel connection. As we can see in this circuit, this I1 current is divided in I1A and I1B, and V1 voltage is appearing across the port 1 of circuit A and B. So current is dividing and same voltage is appearing. It means input ports of circuit A and B are connected in parallel. Similarly, in port 2 of circuit A and B, this I2 current is divided in I2A and I2B, and the voltage V2 is appearing across the port 2 of circuit A and B. So current is dividing and same voltage is appearing across the port 2 of circuit A and B. So at port 2 we have parallel connection. So we can write for port 1 that I1 is sum of I1A and I1B, and this V1 is equal to V1A, and this V1 is also equal to V1B. At port 2, I2 is divided in two parts. I2 is sum of I2A and I2B, and this V2 is V2A, and that is equal to V2B. Now for circuit A, we can write the equations for Y parameter, that is I1A equal to Y11, Y11A, V1A plus Y12A, V2A. This is first equation, and I2A is Y11A, in fact Y21, Y21A, V1A plus Y22A, V2A. This is second equation. And for circuit B, equations are I1B equal to Y11B, V1B plus Y12B, V2B. This is third equation. And I2B is Y21B, V1B plus Y22B, V2B. Now we can see that this at port 1, I1 current is I1A plus I1B. So now we can replace I1A and I1B from equation 1 and 3 to this equation. So we have Y11A, V1A plus Y12A, V2A, and Y11B, V1B plus Y12B, V2B. Here we know that this V1 is equal to V1A, and that is equal to V1B. So we can replace V1A and V1B by V1. So now we have I1 equal to Y11A plus Y11B into V1. And this V2A and V2B both are equal to V2. So we can write Y12A plus Y12B into V2. This is equation 5. Similarly, this I2 current is I2A plus I2B. Now we can replace I2A and I2B from equation 2 and 4 to this equation. So we have Y21A, V1A plus Y22A, V2A plus Y21B, V1B plus Y22B, V2B, this V1A and V1B are equal to V1. So we can write I2 as Y21A plus Y21B V1 plus this V2A and V2B is V2. So we can write Y22A plus Y22B into V2. This is equation 6. So from equation 5 and 6 we can write in matrix form I1 I2 equal to this Y11A plus Y11B and then Y12A plus Y12B and then Y21A plus Y21B and then Y22A plus Y22B and the column matrix V1 V2. So this is the overall Y matrix. It means if two-port circuits are connected by parallel connection, then the overall Y parameter is sum of Y parameters of circuit A and B. So that's how we find the Y parameters of parallel interconnected two-port circuit. Simply the sum of Y matrix of circuit A and B. Now let's see one example. For this circuit shown in figure, we have to find the Y parameters. This is the parallel connected two-port networks. But before solving by interconnection, I will solve it. I will solve for two parameters directly. For that purpose, I am converting this T network to pi network or converting this star connection to delta. Suppose this is R1, this one is R2, this is R3. So this R1 is simply 1 into 1 plus 1 into 1 and then 1 into 1 divided by 1. See, in T network all the resistances are equal, that is 1 ohm. So in delta network or in pi network all the resistances are also equal. So this is also equal to R2 and R3. So R1, R2 or R3 is 3 over 1 or 3 ohm. So now the circuit, let's redraw this circuit. This is T network which is converted to pi. R3 is 3 ohm. R1 is also 3 ohm. It is also 3 ohm. And here we have 1 ohm resistance. This is port 1 and this one is port 2. Now we have the parallel connection of 1 and 3. So parallel connection of 1 and 3 is 1 into 3 over 1 plus 3, which is 3 over 4 ohm. So now the circuit is totally in the shape of pi network. This one is R1, this is R2, and let's write it R3 dash. So now The y parameter for this pi circuit is y11, y12, y21, y22. I am writing in matrix form. 1 over R1 plus 1 over R3 dash, then minus 1 over R3 dash, minus 1 over R3 dash, and then 1 over R2 plus 1 over R3 dash. Now this is 1 over 3 plus 4 over 3, and then minus 4 over 3 minus 4 over 3, and then finally y22 is 1 over 3 plus 4 over 3. Unit is mho. So the y matrix, final y matrix is 5 over 3, then 4 over 3, minus 4 over 3, then minus 4 over 3, and then 5 over 3. So this is the y matrix for the given two-port circuit. I've used the direct method. Now let's solve this circuit using parallel connection. This was the circuit. This is one network and another network is which consists of this 1 ohm resistance, because here current is dividing I1A and I1B. At port 2 also I2 current is divided in two parts, I2A and I2B. Now let's redraw this circuit. T network at the bottom and 1 ohm resistance at the top. And it is connected like this. This is V1, I1, and I1 current is divided in two parts, I1A and I1B. This is V2, current is I2. I2 is divided in two parts, I2A and I2B. And V1 is equal to V1A, and that is equal to V1B. And this V2 is equal to V2A and V2B. Now we can see the two-port networks connected in parallel. Now for this bottom network we can convert this circuit into pi to T or star to delta, and all three resistances are 3 ohm, 3 ohm, and this one is also 3 ohm. For the bottom network or circuit B, we know that the y parameters are 1 over 3 plus 1 over 3, and then minus 1 over 3. This is R1, R2, and top one is R3. So y11 is 1 over R1 plus 1 over R3, and then y12 is minus 1 over R3. Y21 is also minus 1 over R3, and y22 is 1 over R2 plus 1 over R3, which is 1 over 3 plus 1 over 3. So Y parameter for this circuit B is 2 over 3 minus 1 over 3 minus 1 over 3 and 2 over 3. All the units are in mho. And for the top network, we know that we already did this in the lecture of Y parameter, that if we have the resistance R like this, then its Y parameters are 1 over R minus 1 over R minus 1 over R and 1 over R. So if R is 1 ohm, then the Y parameters are 1, minus 1, 1, in fact minus 1 and 1. All the units are in mho. So this is Y parameter for circuit B and this one is Y parameter for circuit A. So the two port networks are connected in parallel. So overall Y parameter is sum of Y parameters of circuit A and circuit B. So 1 minus 1 minus 1 1 plus 2 by 3 minus 1 by 3 minus 1 by 3 and 2 by 3. Now take the addition of these two matrices. So 2 by 3 plus 1 is 5 by 3 and minus 1 by 3 is minus 4 by 3. Minus 1 by 3 is minus 4 by 3 and 1 plus 2 by 3 is 5 by 3. All are in mho. So that's how we find the Y parameter of this two-port network, which consists of two-port networks connected in parallel. So by the two methods, we are getting the same results. 5 by 3 minus 4 by 3 minus 4 by 3 and 5 by 3. Here also 5 by 3 minus 4 by 3 minus 4 by 3 and 5 by 3. So that's how we do the analysis of two-port network, two-port networks connected in parallel connection. Thank you.